Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video, I will discuss the solution for the SCORE PHYSICS SET 1 from Program Kecemerlangan Akademik Unit Fizik Kolej Matrikulasi Negeri Sembilan. And in this video, I will discuss the solution for question number 1 to question number 5. Question 1. The Young modulus of a material is given by equation Y equal to tensile stress over tensile strain. What is the dimension of the Young modulus? For the solution, first step, you need to write down the equation given to you in the question. And second step, you need to write down the dimension equation. For the dimension equation, you need to use the bracket symbol, and inside the bracket, write down the physics quantity. So in this case, the dimension for the Young modulus is equal to the dimension for the stress. Stress is represent F over A. And for the strain, it is equal to delta L per L. The next step is you need to substitute the value for the dimension. For example, F represent MLT negative 2, A area is L square, length L, and the dimension for the delta L is L. Because of that, you will get the dimension for the Young modulus is ML power of negative 1, T power of negative 2. For question number 2A, the speed of a car travelling along a straight road decreased uniformly from 60 meter per second to 12 meter per second over 80 meter. Calculate. Okay, before you do the calculation, first list the information given from the question. So, for example, U is equal to 60 meter per second, and then the speed is decreasing to 12, so final velocity is 12 meter per second, and the displacement or distance is 80 meter. Okay, to calculate the deceleration of the car, we will use the equation of V square equal to U square plus 2AS. Why we choose this equation? Because of you refer to the given information. You can substitute all the information inside the equation, and you will get the deceleration of the car negative 0.7 meter per second minus 2. Do take note that for the deceleration, A supposed to be negative. For question number 2, the time taken, you need to calculate the time taken for the speed to decrease from 16 to 12 meter per second. Because of that, you can use equation V is equal to U plus AT, and then substitute V, U, and also A that have been calculated in 1. You will get the T, which is equal to 5.71 second. Question 2B. An object is thrown horizontally from the edge of a table with an initial velocity of 3 meter per second. If the height of the table is 2 meter, calculate the final velocity of the object and the horizontal displacement. Referring to the question, list the information given. And we will get that 3 meter per second is represent Ux. Because of this is half projectile motion. And Uy is equal to 0 because of at the maximum height. H is equal to negative 2 meter because of we refer to the displacement at the y component, and referring to the definition of displacement from initial to final point in the straight line, as is not at the y or x component, we need to resolve. From the resolving vector, we get that Sy is downward, that's why our H is negative, and Sx as shown. The first question, you need to calculate the final velocity of the object. Final velocity meaning that you need to calculate the magnitude and also the direction. Okay, and where the velocity that you need to calculate is just before the object reach the floor. You need to know, to get the V, you need to know the Vx and Vy. So Vx for the projectile motion, at any path on the projectile motion, Vx is equal to Ux. Because of that, Vx is equal to 3 meter per second, no need to calculate. For the Vy, you need to calculate using equation Vy square equal to Uy square plus 2Asy. We have the value of Uy, which is equal to 0, and A is negative 9.81, Sy is negative 2. When you calculate, you get the Vy is equal to 6.26 meter per second. To calculate the magnitude of V, we will use this equation, and after you substitute, you will get that the value for V, the magnitude of V is 6.94 meter per second. And for the direction of the velocity, you need to calculate the theta. Theta is equal to 64.4 degree. For question number 2b2, to calculate the horizontal displacement of the object, we know that the equation for the displacement, horizontal displacement, is Sx is equal to uxt. The information given is ux, so we need to calculate the t first. You can use the equation of Sy equal to uyt plus half at square. And then from this equation, you can get the value for t. Substitute the t in the Sx equation. You will get that the horizontal displacement is equal to 1.92 meter. Question number 3a. A fisherman on a stationary boat jumps off onto a jetty with a velocity of 1.5 meter per second, causing the boat to move backward. Alright, referring to the question. We will get that the final velocity for the fisherman, Vf, is equal to 1.5 meter per second. And the hidden info is, because of fisherman and also the boat is initially stationary, so U for the fisherman and boat is equal to 0. First question is, if the mass of the fisherman and boat are 65 kg and 450 kg, determine the velocity of the boat. So to calculate the velocity of the boat, we will use the principle of conservation of linear momentum, which is initial momentum, linear momentum, sum of initial linear momentum is equal to sum of final momentum. And then initial momentum is mf plus mb times with u equal to mfvf plus mbvb. Substitute correctly, referring to the information given from the question, and you will calculate the VB, which is equal to negative 0.217 meter per second. VB is the velocity of the boat. Negative sign shows that the boat is moved backward. To calculate question number 3a2, if the fisherman feet are in contact with the jetty for 10 milliseconds, so 10 milliseconds is equal to 0.01 second, determine the magnitude of the average force exerted on his feet. So to calculate the average force exerted on his feet, we will use the impulse-momentum theorem, where J is equal to change of momentum. J is represent impulse, and J is also equal to F delta T. Because of that, when you substitute the value inside the equation, you will get that the F is equal to 9,750 Newton. Question 3b. Figure 1 show an object of mass 2 kg placed on a rough plane inclined at 30 degrees with the horizontal. The coefficient of kinetic friction between the object and the plane surface is 0.25. A constant horizontal force F is equal to 50 Newton. Act on the object and push it along the inclined plane with acceleration A. From the question, list all the information given. And for question number 1, you need to sketch a free body diagram showing all the forces acting on the object. To sketch the free body diagram, first you need to identify that object is represent point object and the inclined plane is represent the x component. Of course, perpendicular to the x component, there is y component. And after that, identify the forces exerted on the object. The first force is weight. And then we have normal force, which is perpendicular to the surface in contact. Friction force is opposed to the direction of motion of the object because of the object is moving up the inclined plane. And of course, there is an external force exerted on the object. Do take note that when you sketch a free body diagram, the tail of all forces supposed to exerted on the point object. For question number 3b2, you need to calculate the acceleration of the object. To calculate the acceleration, first identify from the free body diagram. My suggestion is don't use your answer in one. I want you to sketch back the free body diagram, and then when you resolve, just resolve on the second free body diagram. So because of that, firstly, because of F, the external forces not located at the X or Y component, so you can resolve to the Fx and Fy. W is also not at the X and Y component, so you need to resolve to Wx and Wy. Then identify the theta, the angle where theta is equal to 30 degrees. Okay, when your diagram is complete, we want to calculate the acceleration of the object. If you refer to the diagram, acceleration is at the x component. So from the x component, we do the analysis starting from the x component, where total forces exerted at the x component is equal to ma. What forces exerted on the x component? So we have fx, okay, because of the direction is same direction with the acceleration, so fx is positive, wx is negative, and friction force, which is equal to mu n, is negative, oppose the direction of motion. Fx minus wx minus mu n is equal to ma. When we want to calculate the acceleration a, we do not have the value for n, normal force. And if you look at the diagram, normal force is at the y component. Because of that, we do analysis at the y component, where at the y component, total forces at the y is equal to 0 because of the object is not moving upward or downward. Take a look all the forces exerted at the y component. There are normal force, which is upward, Fy, and Wy is downward. So we get that n minus Wy minus Fy is equal to 0. And when you substitute the value where Wy is equal to 50, Wy is 2 times 9.81 cos theta, cos 30, and Fy is 50 sin 30. You get n is equal to 42. Substitute in the equation at the x component, and you can calculate the a. The acceleration of the object is equal to 11.5 meter per second. Question 4a. An object of mass 2 kg travel along the horizontal floor under the action of force F. Figure 2 shows the graph of F against displacement S. The speed of object at S is equal to 0 is 10 meter per second. Determine the kinetic energy of the object at S is equal to 10 meter. Referring to the question, list all the information given following the correct symbol. And from the graph of F versus S given, we can calculate the work done on the object, which is represent the area under the graph. Because of that, you will get that the work done is equal to 32.5 joule. From the work done, because we want to determine the kinetic energy, we can use the work energy theorem, where the work energy theorem states that the work done is equal to the change in kinetic energy. So for the change in kinetic energy, K final minus K initial, we need to calculate the kinetic energy when S is equal to 10 meter, meaning that it is final kinetic energy. When you substitute the value for work done that we have calculated earlier, and also the half mu square, you will get that the final kinetic energy is equal to 132.5 joule. For question number 4b, an object of mass 2 kg is placed 30 cm directly above the top end of a vertical spring as shown in the diagram 3. It is then released from that height. The spring constant K is 2000 Newton per meter. You need to calculate the speed of the object just before it strikes the spring. So, to calculate the speed of the object just before it strikes the spring, I just label the diagram at the top and at the bottom where we want to calculate the speed at the bottom. Okay, so we will use the principle of conservation of mechanical energy, which is the total energy at the top is equal to total energy at the bottom. Basically, kinetic energy plus potential energy at the top is equal to kinetic energy and potential energy at the bottom. At the top, initially it is at rest, so kinetic energy is equal to 0, U is equal to mgh. And at the bottom, because of at the lowest point, so the potential energy is equal to 0, kinetic energy is equal to half mvb square. We want to calculate the vb, so we can cancel the m because both sides there is an m. And if you substitute the value, you will get that the speed of the object just before it strikes the spring is 2.43 meter per second. For question number 4b2, we need to determine the maximum compression. Okay, to calculate the maximum compression, take a look at our new diagram. Here, I just label at the top of the spring is initial point, and when the spring compress x, so it is a final point. To find the compression x, we will use the principle of conservation of mechanical energy too, where the total initial energy is equal to total final energy. The energy that involved at the initial point is kinetic energy and potential energy. At the final point, after the spring is compressed, it is the potential energy of the spring. And the equation for the initial kinetic energy is half mvi square. Vi is represent the initial the speed of the object just before it strike the spring, meaning that before it compress, the initial velocity is same with the initial velocity at the bottom. And then the potential energy is equal to mgx because of the spring will compress x at the distance of x, and the potential energy of the spring is half kx square. When you substitute the value and do the calculation, you will get that the x is equal to 0.087 meter. Question number 5 is from topic 5, which is about the circular motion. Okay, take a look at the question. A 900 kilogram car moving at 10 meter per second takes a turn around a circle with a radius of 25 meter. Okay, referring to the question, list the information given, and then you need to determine the angular velocity of the car. So the angular velocity of the car, we can use equation V is equal to R omega, and then V is 10, R is 25, so the angular velocity is equal to 0.4 radian per second. For the period of motion of the car, because we have the value for angular velocity, so you can calculate, you can use the equation of omega equal to 2 pi t. T is the period, you substitute omega 0.4, you will get the period is equal to 15.7 seconds. The third question is you need to calculate you need to determine the net force acting upon the car. So this is the net force is a very important concept in the circular motion, because of the net force is actually equal to the centripetal force. The centripetal force is equal to mv square over r. We just substitute all the value given to you in the question. You will get that the net force acting on the car is 3600 Newton. Okay, so that's it for the first part of the discussion of the solution for SCORE Physics Set 1. I will continue for the second part in my next video. Thank you for watching. Thank you for listening. Wish all of you good luck and all the best for your PSPM. Thank you so much.